Is there gender bias in admissions in elite universities? A question like this is fraught with cultural significance, with ethical and moral issues, and possibly legal liability. In 1973, at the University of California at Berkeley, 44% of male applicants were admitted into graduate study, while 35% of female applicants were admitted to graduate study. This appears to be incontrovertible evidence that men were favored over women in admissions. A study was done on Berkeley admissions data by Bickel, Hamill, and O'Connell and published in 1975, and the conclusions were possibly paradoxical. So let us explain and figure out what the setting was that they discovered. We shall use the Berkeley study as a guideline, and of course a modern university will have several thousands of applicants and a vast number of possible departments into which these applicants will apply, and it'll be difficult to sift our way through all these myriad of complexities. Let us borrow from the Berkeley study and imagine a sanitized view of an application process in a mythical university and two stereotypically driven fanciful departments. Say the Department of Social Warfare and the Department of Marchismatics. So in this made-up study, there are 440 applicants, 220 men and 220 women. The women applied in a number of 200 to the Department of Social Warfare, and of the 200 applicants, female applicants to social warfare, 20 were admitted. 20 women applied to the Department of Marchismatics, and 19 were admitted. On the side of the men, 20 men applied to the Department of Social Warfare, 1 was admitted. 200 men applied to the Department of Marchismatics, and 100 were admitted. Now, if we aggregate this data for the entire admissions process, we find that cumulatively 39 out of 220 women were admitted to graduate study in this fictional university, while 101 men out of 220 were admitted to this university. And when we look at the admissions ratio, we find that for female applicants, roughly 18% were admitted, and of the male applicants, roughly 46% were admitted. This is in favor of the men by about 2.5 men to each woman. It appears to have contained incontrovertible evidence that there is a strong bias in favor of the men. But wait a minute, let's take a more fine-grained look at this picture. Let us take a look now at the admissions information to the individual departments. Now, when you look at social warfare, 20 out of 200 women were admitted for an admissions rate of 10%. 1 out of 20 men were admitted for an admissions rate of 5%. In Marchismatics, 19 out of 20 women were admitted for an admissions rate of 95%. And 100 out of 200 men were admitted for an admissions rate of 50%. And one finds, looking at these ratios, that rather unfairly, these inequalities have changed directions. Women are almost twice as likely to have been admitted in this made-up study to each individual department. But men are more than twice as likely to have been admitted to the university. A paradox. Or is there one? On closer examination, one finds the explanation of the seeming paradox. Women in the study were much more likely to apply to a much more selective department. And so even though women were more likely to be admitted to each of the individual departments, collectively, fewer women were admitted. Now, this illustrates the perils of jumping to conclusions by a rough and ready aggregation of data willy-nilly. In this instance, an aggregate of data conceals essential evidence that women in the study were applying to more selective departments, and as a consequence, fewer women were admitted. It'll be worth putting some notational and mathematical framework around it so that we can see this in fair and just proportion. So let's look at the study again anew, and at this time, let's try to identify a proper probability space and a model for chance for this picture. And so, what is a sample space for the problem? Well, the sample space constitutes the 440 applicants to this university. 220 men, 220 women. What constitutes a chance experiment here? Imagine now we have this pool of 440 applicants. We reach in blindly and pick an applicant at random from the pool. Random selection implies a combinatorial setting where any one of the 440 applicants is equally likely of selection. Now, once you select an applicant, certain attributes of that applicant now will become visible. First, at a high level, was that applicant admitted to study, graduate study at the university, or rejected? Let's call that event A. A, the event that the applicant chosen randomly was admitted. A complement that the event that the applicant was rejected. That applicant could be male or female. Let's call W the event that the chosen applicant was a woman. W complement then means that the chosen applicant was a man. And that applicant could apply to one of two departments. Let S represent the event that the applicant applied to the Department of Social Warfare. Let S complement, therefore, denote the event that the applicant applied to the Department of Marcusmatics. Now, here is a fine-grained view, a department-specific view of the applications process. What we discover is that the probability that the applicant is admitted, given that the applicant is a woman and applies to the Department of Social Warfare, exceeds the probability that the applicant is admitted, given that the applicant is a man applying to social warfare, in odds ratios of 10% to 5%. Likewise, we find that the probability that the applicant is admitted, given that it is a woman applying to Marcusmatics, the second line in your picture, exceeds that of the chance of the applicant being admitted, given that it is a man applying to the Department of Marcusmatics, in the odds of 95% to 50%. Now, this is the fine-grained departmental specific view, and these conditional probabilities capture the essence of our mathematical observation. What about the aggregate view for the university at large? Remarkably, we find that it is possible, in spite of departmental tendencies going in one direction, for the aggregate tendency to go in the opposite direction. The chance that the applicant is admitted, given that it's a woman, is smaller than the chance of the applicant being admitted, given that it is a man. The odds of 18% to 46%. Remarkable. This paradox has been known for a long time, for more than a century. It was remarked by Yule in 1903, but it was articulated wittily with a handsome range of interesting and intriguing examples by E.H. Simpson in 1951, and therefore it's named after Simpson. The paradox arises in a multitude of common settings. Replace this fictional university by, for example, the reaction of women and men to two different drugs treating in a particular ailment. Say we find that women do better than the men on each of the two drugs. Does that mean that women do better overall? If you aggregate the information, you might find that fewer women benefit than men do. And it's the same paradox. Again, here, the fine-grained information is of relevance, and a crude aggregate here conceals and distorts the picture. Right? We could replace the sexes, the genders, by, for example, people from two different ethnic communities, given two different drugs to treat a particular ailment. And again, we have a basis for a seeming paradox. Of course, in that instance, you might find that a more efficacious drug is given in larger percentage to a particular ethnic community because of economic or cultural constraints, and a less efficacious drug is given to the other community in larger proportion, again because of these economic or cultural constraints. There are settings also where the aggregate might have more information than the fine-grained in picture. For example, imagine now that we are looking at our returns in a financial setting for a portfolio of a given size. And let's say we are looking at investments in two different investment vehicles in different proportions. In one case, we find that for each particular investment vehicle, one strategy, one proportion does better than the other. But in aggregate, the second strategy does better than the first. Now, in a picture like this, arguably, the aggregate is perhaps of first importance to the individual, because one might ask, what happens to my entire portfolio in terms of my returns on investment overall? How is my wealth growing? As opposed to how are the individual segments growing? These paradoxes seem to appear on a routine basis in the popular news, almost on a yearly basis. Right? For our purposes, it's an amusing story. It points to a cautionary tale that one should be careful in how we aggregate or lump information together. And it reinforces our slogan: conditioning affects event probabilities in strange and wondrous ways.